And finishing up chapter 9, today we're going to talk about reference angles and exact angle measures based off the unit circle and our special right triangles. So let's start with what are reference angles. Reference angles is an acute angle formed by the terminal side and the x-axis. Those are the two most important things. Always going to the x-axis, and it has to be an acute angle. Now remember, an acute angle has to be between 0 and 90. Your acute angle can't be any more than 89.9999. And of course, it's an angle measure, so it's not going to be a negative value. So that's the other thing, is reference angles won't be negative. Yes, we have negative angle measures that we're drawing going clockwise on our coordinate system, but when we're talking about reference angles, they're not going to be negative. Find the reference angle and state the quadrant of the terminal side. So let's start with our negative 130 there. Negative means we're going clockwise, so 0, negative 90, negative 180. Negative 130 is in between negative 90 and negative 180, which is in quadrant 3. I'm going to draw 130 right here. And now for the reference angle, remember you have to go to the x-axis. The x-axis is 180, so I have to come here. And I want to know, what is this angle tucked up here in the corner? What is that theta? So what is the difference from 130 and 180? Well, we can do 180 minus 130, and we get 50. So our reference angle is 50 degrees. $575. Well, we know 575 is more than 360. So I'm going to subtract 360 to find out how much more is 575. Well, that's a full circle plus another 215 degrees. This is a positive angle measure, so we're going counterclockwise. 270. And 215 is going to be roughly about right here. So we want a full circle around, and then another 215 degrees. We are in quadrant 3 again for our terminal side. Our reference angle, again, our nearest x-axis is 180. So we're looking for this reference angle tucked right up in there. Your reference angle is always going to be tucked into the origin. Always, always, always. So we need to know the difference from 215 to 180. Remember, it's always a positive reference angle. So 215 minus 180 gives us a reference angle of 35 degrees. Five pi over 3. 5 pi over 3 is in radians. So I'm going to look at our radians. It's positive, so we're going counterclockwise. So we have 0, pi over 2, pi, 3 pi over 2. So 5/3. Is it more than 3/2 or less than 3/2? Because we know it's more than 1. And we could also reference our unit circle or our unit circle plates to see 5/3 there. And we see that 5/3 is here in quadrant 4. Right here. So we came around positive, and we have 5 pi over 3. So our terminal side is in quadrant 4. Our nearest x-axis is right up here. Since we're almost all the way around, we're almost to 2 pi. So we're doing 2 pi minus 5 pi over 3 to find our reference angle. Common denominators gives us 6 pi over 3 minus 5 pi over 3, which means that our reference angle is 1 pi over 3. You could do the conversions to change those into degrees. If you did the conversion to change it into degrees, then 5 pi over 3 is 300 degrees. 300 degrees is still over here in quadrant 4. And our reference angle still comes up here to our nearest x-axis, and we're looking for that angle right there, always the one tucked up, touching x and in the origin. And so you're doing 360 minus 300, which is 60 degrees. The thing is that if you do this conversion, you can't leave the 60 degrees. You need to convert it back into radians because you always want to give your answer back in the same units that you were given the problem. So since our problem were in radians, you do the conversion from 60 degrees, and that would be pi over 3. Our last one, negative 7 pi over 3. So we know we're going clockwise. 0, negative 2 pi, negative pi over 2, negative pi, negative 3 pi over 2. So I think 7 pi over 3 is more than one trip around. So I'm going to add 2 pi to see if indeed we took a whole trip around the circle and then did some extra. Remember, we need to have common denominators, so I'm adding, multiplying by 3 here to make it 7 pi over 3 plus 6 pi over 3, which gives us negative 1 pi over 3. So we did make it a whole trip around, and negative pi over 3 brings us all the way around and down over here. So our terminal side is in quadrant 4 again. For our reference angle, our nearest x-axis is again up here at 0 and 2 pi. And we're looking for this reference angle right here, touching the x-axis and tucked up into the corner of the origin. 1 is closest to 0. So we want to know what is the difference between pi over 3 and 0. So pi over 3 minus 0 is pi over 3, making our reference angle pi over 3. Remember, it's not going to be negative because we're talking about a reference angle. All right, we are going to come now to these examples. We'll do examples 5, 6, 7, and 8. And always want to start with drawing your coordinate grid and your terminal side. So 240 degrees, it's positive, so we're going counterclockwise. And we are here in quadrant 3. Want to get my reference angle. So our nearest x-axis is here at 180 degrees. So 240 minus 180 gives us a reference angle of 60 degrees. Okay, so that makes this 30, 60, 90 triangle. 30 always has a length of 1, opposite it. 60 has a length of the square root of 3, and the hypotenuse is 2. Now here's the difference. I need to check to see. Our hypotenuse is always going to be positive, but the one up here opposite the 30 degrees is a negative 1 because we're on the left side of our x-axis. The square root of 3 is going down below the positive on the y-axis. So this is a negative square root of 3. Now I can take a look at the fact that it's asking me for sine. Sine is opposite over hypotenuse. I'm going to go ahead and label from our reference angle. This is opposite, adjacent, hypotenuse, OH, opposite hypotenuse. We have negative square root of 3 over 2. And so that is my sine of 240 degrees in exact value. I'm not typing this in the calculator. Let's try the next one. Example 6, 17 pi over 6. Let's again check to see if maybe we went a full circle around and then more, so we can find out how much more we have to go around. We're going to subtract 2 pi from that because remember 2 pi, 360 degrees, that's a full circle around. So I'm going to multiply by 6. We have 17 pi over 6 minus 12 pi over 6, which is 5 pi over 6. 5 pi over 6 is over in quadrant 2. It's positive, so we know we're going counterclockwise. There's 1 pi. 5 pi over 6 is right here. Our nearest x-axis is here at pi. So to find our reference angle, we have 1 pi minus 5 pi over 6. Make common denominators. This 1 pi is 6 pi over 6. So 6 pi over 6 minus 5 pi over 6 is 1 pi over 6. So our reference angle is pi over 6, or 30 degrees. Opposite the 30 degrees is a length of 1. That makes this 60 and makes this the length of square root of 3. And our hypotenuse is 2. Remember, hypotenuse is always positive. So let's take a look at our 1. The length of 1 is going up on the y-axis, so that's positive. The square root of 3 is going left on the x-axis, so that's negative. Now that I have all of that in place, it's asking me for secant. Secant is the inverse of cosine. So the secant is hypotenuse over adjacent. From our reference angle, this is opposite, adjacent, hypotenuse. So we have 2 over negative square root of 3. Remember that we have to rationalize our denominator. So square root of 3 times the square root of 3 gives us a secant of negative 2 square root of 3 over 3. Tangent of negative 240 degrees. Negative 240 is going clockwise. So filling in here, negative 240 is here. Our nearest x-axis is down here at 180. So 240 minus 180 gives us a reference angle of 60 degrees. That makes this a 30, 60, 90 triangle. The length opposite 60 is the square root of 3. The length opposite 30 is 1. The hypotenuse is 2. Hypotenuse is always positive. Square root of 3 is going up in the positive direction for y, so it's positive. The 1 is on the left side of 0. It's going in the negative x direction, so that's negative. I'm going to label my O, A, and H. Tangent. Tangent is TOA. My opposite is the square root of 3, and my adjacent is negative 1. So our tangent is the negative square root of 3 over 1, or you can just write the negative square root of 3. Example 8, 7 pi over 4. That's a positive angle, so we're going counterclockwise. Fill in my radian measures. 7 pi over 4 is more than a half, or 1.5, 1.5. 7 pi over 4 is here. Our nearest x-axis is here, and it'll be closest to 2 pi. So 2 pi minus 7 pi over 4 Common denominators makes that 8 pi over 4 minus 7 pi over 4, which is 1 pi over 4. Our reference angle is 1 pi over 4. 1 pi over 4 is the same as 45 degrees. So this triangle is a 45, 45, 90 with lengths of 1 for its legs and square root of 2 for its hypotenuse. Hypotenuse is always positive. Up on the top, that 1 is on the positive x-axis, so it stays positive. On the right side, that 1 is going down below in the negative y, so that's a -1. Again, we have secant, which is hypotenuse over adjacent, because it's the inverse of cosine. Our hypotenuse is the square root of 2. Our adjacent is 1. We can leave it this way, or we can write the square root of 2. Your task for double credit on this set of notes is to do this for next class. All right. Have a great night.